Hello students, in this lecture I am going to discuss about the lead system that is used for the measurement of electrocardiogram. What happens, as I have already told you, the heart muscles, they generate biopotentials, and these biopotentials, when they reach the surface of the body, they are picked up by the electrodes, and then from the electrodes, after passing through the amplifiers and signal processing circuitry, when they are displayed, the result that we that is the graphical representation that we get, is the electrocardiogram. So what I am trying to tell is that for recording the electrocardiogram, we need electrodes. For recording the electrocardiogram, we need electrodes, and in this lecture I am going to discuss about the electrodes and lead system, or you can say the arrangement of electrodes, the arrangement of lead system. In this lecture I will be discussing for the measure that is used for the measurement of electrocardiogram. So here whenever I will be using the term lead, here the lead means it indicates a particular group of electrodes and how they are connected to the amplifier. In the subsequent slides I will be showing that the leads are connected to the amplifier. This is the amplifier, this is the amplifier. So leads means here in this topic, in regarding this topic, the term lead will mean the particular group of electrodes and how they are connected to the amplifier will tell the lead. So in different combinations we will have different leads, like lead 1, lead 2, lead 3. In different combination of electrodes we will have different designation of lead. So going back to the previous slide, so this thing, I hope it is clear that lead means the particular group of electrodes and how they are connected to the amplifier. Now what happens, these leads or the electrodes that are used here, they are used for recording, they are used for recording the electrocardiogram. Now the heart muscles, while they are pumping, they are in pumping action, that is the pumping action of the heart, will generate voltage, and this voltage is actually a vector quantity whose magnitude as well as spatial orientation will change with time. So the voltage generated because of the pumping action of the heart is a vector quantity whose magnitude as well as spatial orientation will change with time. Now since this ECG signal is measured from the electrodes, and these electrodes are applied to the surface of the body, you getting my point? What I am trying to say, suppose these are the electrodes. Here 5 electrodes are used, like in the right arm, in the left arm, then this is the chest electrode, we have electrode in right leg, then we have electrode in left leg. So all total 5 electrodes. So what happens, these electrodes are used for recording the ECG signal. So the waveform of this ECG signal is very dependent on the placement of electrodes. That is, some of the segments of this ECG signal may however almost disappear for certain electrode placements, whereas other may show up clearly on the recording. And for this reason, in normal electrocardiographic examination, the electrocardiogram is recorded from a number of different leads, usually 12, to ensure that no important detail of the waveform is missed. So what I am trying to say is that these are the, first of all, you just get this point, these are the 5 electrodes that we are going to use in our future these are the 5 electrodes that we will be using for recording the electrocardiogram. These are the 5 electrodes, just remember this thing. And now how these electrodes are combined to the amplifier will tell you the designation of the leads. So in this way we have different leads depending upon the electrode pairs or depending upon the electrode combinations and their connection to the amplifier, and each combination will tell you about the ECG waveform. Like each combination will give you the ECG for waveform. Some trace will be some recordings will be fade, some recordings will be more clear. In all total we will be recording from all the lead combinations, and we will use it for representing the electrocardiogram. Now the placement of electrodes as well as the color code that is used to identify each electrode is shown here. As you can say, the right arm is given the white color, the left arm is given the black color, the chest is brown color. So the electrodes, the color code has been given to the electrodes to identify them. Now it was found by Intervin that it is advantageous in order to record the electrocardiogram from electrodes. It would be advantageous if the electrodes are placed vertically as well as horizontally on the human body. So as you can see here in this diagram, when I was discussing the immersion electrodes, you can see the patient is having his hands, having his both arms, you can see both arms as well as his leg placed into the earthenware crooks which are used as immersion rods. These are the earthenware crooks which are used as immersion rods. So it was found by Intervin that it is advantageous to record the electrocardiogram from the electrodes which are placed horizontally as well as vertically. So both the arms were used for this purpose, both the arms in the sense both the electrodes were placed on the arms for used for this purpose, and as well as the electrode that was placed on the on the left leg was used for this purpose, and the left leg was chosen because it terminates vertically below the heart. So the early electrocardiograph machines thus used 3 electrodes, of which only 2 were used at one time, and with the introduction of electronic amplifier, you can see with the introduction of the electronic amplifier, an additional connection to the body was needed as a ground reference. So although an electrode could have positioned almost anywhere on the body for this purpose, but it became convention to use the free right leg. So you can see here, these are the electrodes. These are the this is the right electrode, right arm electrode. This is the left arm electrode, and this is the right leg. So all total we have 3 electrodes which are used in the electrocardiograph machines, in the previous electrocardiograph machines, like this right arm electrode, left arm electrode, and this left leg electrode. But out of these 3 only 2 are used, either this right arm and left arm, or either this right arm and left leg, or this left arm and the left leg, and the remaining right leg electrode is used as the ground reference, as we have used an electronic amplifier here. Then chest or precordial electrodes were introduced later. We have this chest electrodes also, the chest and precordial electrodes, they were introduced later. And although plate electrodes are normally used for the electrodes at the extremities, means at the electrodes which are used in the arms and legs, they are the plate electrodes, whereas the chest electrode is of the suction type. Suction type electrodes are used in the chest area. Now coming to the leads combination. So in the normal electrode placement, as you can see, 4 electrodes are used to record the electrocardiogram. The electrode on the right leg is only for ground reference. So this much is clear. Now the input, because the input of the ECG recorder has only 2 terminals, so a selection must be made among the available 3 active electrodes, like this right arm electrode, then this left arm electrode, and this left leg electrode. So we have this 3 active electrodes, and among these 3 active electrodes we need to choose any 2, because the input of the ECG recorder has only 2 terminals, and this right leg electrode, that is used as the ground reference. Now the 3 bipolar limb lead selections first introduced by Enthoven is shown here, as you can see. Lead 1, lead 2 and lead 3. These are the three combinations. So lead 1, lead 2, lead 3. Lead 1 is between the left arm and the right arm, you can see, between the left arm and the right arm. Lead 2 is between the left leg and the right arm, and lead 3 is between the left leg and the left arm. So these three leads are called bipolar because for each lead the electrocardiogram is recorded from 2 electrodes. As you can see, the electrocardiogram is recorded from 2 electrodes. That's why bipolar is used here. Now, in working with electrocardiograms from these three basic limb leads, Enthoven postulated that at any given instant of the cardiac cycle, the frontal plane representation of the electrical axis of the heart, as you can see in this slide, the frontal plane representation of the electrical axis of the heart is a two-dimensional vector. So this is the cardiac vector. This is the cardiac vector. This is the two-dimensional electrical axis of the heart. Now the ECG measured from any of the three basic limb leads. Now here I have shown the limb leads. This is lead 1, this is lead 2 and this is lead 3. So combining these three, we have lead 1, lead 2, lead 3. The same combination, lead 1, lead 2 and lead 3. So I have drawn this lead 1, lead 2 and lead 3, and joining this lead 1, lead 2, lead 3, the triangle that we get will be the Enthoven triangle, and this is the cardiac vector. So electrocardiogram recording measured from any combination, like from lead 1 or lead 2 or lead 3 combination, the electrocardiogram measured from any combination, it is actually the single dimensional component of that cardiac vector. So this is the cardiac vector. So electrocardiogram measured from any combination, like if it is measured from lead 2, so it is the single dimensional component of this cardiac vector. Electrocardiogram measured from lead 3 is the component of this cardiac vector. Now the other leads, as you can see here, they are of unipolar type, which was introduced by Wilson in 1944. So for unipolar leads, the electrocardiogram is recorded between a single exploratory electrode and the central terminal, which is having a potential corresponding to the center of the body. As you can see, this is the amplifier. Here also the right leg is used as the ground reference. Here the right leg is used as a ground reference, and the combination of the electrodes is like we have 3 active electrodes. So one will be the exploratory electrode and will take the summation of the, or you can say average of the other 2 electrodes. So in unipolar electrode, the electrocardiogram is recorded between single exploratory electrode and the central terminal, which has the potential corresponding to the center of the body, and this central terminal is obtained by connecting the 3 active limb electrodes together through resistors of equal size. So initially what used to be done, as here you can see, only the combination, only the summation is taken from these 2 electrodes. Initially what used to be done, one is the exploratory electrode and the summation used to be taken from the 3 electrodes only. Exploratory electrode was also involved previously, but it was seen that the potential at the connection point of the resistor correspond to the mean or average of the potential at the 3 electrodes, and in the unipolar limb leads, one of the limb electrodes is used as exploratory electrode as well as contributing to the central terminal. So this is the exploratory electrode and it is also contributing to the central terminal, and this double use actually results in the ECG signal that has a very small amplitude. So that was the drawback of unipolar limb lead. Now this is the augmented unipolar limb lead that I have shown here. What I am trying to say is that in unipolar limb lead, how was the combination? One electrode was used as the exploratory electrode, one electrode was used as the exploratory electrode, and the central terminal was taken from the 3 electrodes, like exploratory electrode and the other 2 electrodes. So what happened? Because of this, the ECG recording, the amplitude of the ECG was very small. Here also you can see, this is the another combination. Here this is the exploratory electrode, in this case this is the exploratory electrode, and the central terminal is taken from the rest of the 3. This was in the case of unipolar limb leads. Now in order to rectify this problem, like the small amplitude of the electrocardiogram, what happened? Augmented unipolar limb leads were taken. In augmented unipolar limb leads, the limb electrode used as exploratory electrode is not used for the central terminal. As you can see here, this is the exploratory electrode, but it is not used for calculating the central terminal. The central terminal is calculated from the rest of the electrodes. Here also you can see this is the exploratory electrode, and the central terminal is calculated from the rest of the electrodes. So in this way, in augmented unipolar limb lead, we do not use the exploratory electrode for calculating the central terminal, and therefore we, depending upon the combinations, like which is the exploratory electrode and from where the central terminus is, from which electrodes the central terminal is observed, depending on that we have different leads, like lead AVR. Here we have lead AVR, then we have lead AVL, then we have lead AVF. So these leads are designated as lead AVR, AVL and AVF. Now for the unipolar chest leads, for unipolar chest leads, a single chest electrode is sequentially placed on each of the 6 pre-designated positions on the chest. So there are 6 pre-designated positions, as you can see, V1, V2, V3, V4, V5, V6. These black dots are the 6 pre-designated positions on the chest where an electrode can be placed. Fine. So these pre-designated chest positions are called precordial unipolar leads and are designated V1, V2, V3, V4, V5 and V6. And all the active 3 limbs, what happens in case of chest, what we do, we position one electrode, we take that electrode as the exploratory electrode, and we take the central terminal from the rest of the electrodes, like this left arm electrode, right arm electrode, and then this left leg electrode are used for calculating the central terminal, and the chest electrode can be in any of these positions. So in this way we have different combinations here. Now what I am trying to say, as you can see here, how many electrodes are used? All total 1, 2, 3, 4, 5. All total 5 electrodes are being used for recording the electrocardiogram, and different lead combinations are taken out, like different lead combinations. What I am trying to say, like lead 1, will, for recording the electrocardiogram, we need lead 1, we need the ECG that has been recorded from lead 1 combination, we need the ECG that has been recorded from lead 2 combination, we need the ECG that has been recorded from lead 3 combination. In this way we will take all the lead combinations, will take out the ECG from there and will use it for the analysis purpose, because some traces will give you more clear representation, some traces will give you slightly unclear representation. In this way we need all the traces. So in this way now you can calculate how many traces we will get. Let us calculate. This is lead 1, 1, 2, 3, lead 1, lead 2, lead 3. Then we have lead AVR, lead AVL, AVF, that is 4, 5, 6. Now 6 and then 7, 8, 9, 10, 11, 12. We'll get all total 12 ECG recordings from this 5 electrodes. And how 12? Because here the electrodes will be placed in all the 6 positions of the chest for getting the remaining of the 6 lead combination electrocardiogram. So this was all about leads electrode system. I am ending this lecture here. Thank you.